Hello, this is Richard Collins with the Internet Foundation. And I was taking a break today reading an old book on nuclear reactors, and it gave a number of fission reactions. And I said, well, maybe the fission products are stored in a database somewhere. As I went looking, one of the first things I came across was this Fundamentals of Nuclear Physics there. And let's see, I was about down to here, and I said, that looks really interesting. I've always been interested in neutron resonances, and especially for these light nuclei. And, some of the sort of earliest experiments. I said, well, I wonder if I could find the information on that one. So I was reading on down a little bit more, and I was trying to remember, what's the tag that I need to look for. So evaluated nuclear data file. So I searched on that, and let's see, where did it go? Came in here. This one was NDS. There evaluated. That looked a little busy and complicated, so I took the simpler one, which was the second one, which is here. Let me go forward again. I got to this. This is faded, by the way. I would give this a bad grade from the Internet Foundation point of view because it's so hard to read. You don't put faded, thin, pastel text characters onto gray background. And this one is sort of ambiguous. It's just sort of a word there. It doesn't look like a title, so make it proper case or make it visible. You got a lot of stuff going on this page here, and I'm sure it's interesting. This fails my number one criteria for most websites is if you only have one page worth of material, don't spread it out over two pages and make people scroll. So I'm just going to throw in everything. And look, give me a chance, to do something before you start trying to grab my attention for things you want me to sign up for. Okay, so I went to the database. Well, this looked kind of busy. Same thing, a lot of stuff going on up here at the top. Then you use small letters because you're using up all your screen space, and then here. So this is kind of let me check my size. Now I'm at 100%. So I do this pretty fairly when I'm reviewing things. If I keep it at 100%, I expect standard readable characters at that. And if you aren't doing it, then I don't know. I can't force you, but I can just tell you there. So these are relatively small. Somebody's got good eyes in there. These notes in here, news and history. I'm sure there's a better way to do this. I could show you if I have time sometime. But anyway, all right. So I came in here, and there's a cross section, angular distributions. I'm fascinated with angular distributions. I studied nuclear physics. I worked for Detroit Edison for a short time on their Fermi 2 boiling water reactor. And I met one of the engineers from Fermi 1, which is a sodium-cooled reactor. So I did pick up some stuff there. And then when I was at Georgetown University working in the Center for Population Research, I went over in my spare time to the chemistry department. I studied nuclear physics, magnetic resonance, electrochemistry, and a couple of other things. Let me make sure it's in. Let's see. Okay. So anyway, so I have a sense of some of these things, and I'm pretty good on models and calculations. So energy distribution, secondary particles, energy angle distributions, cross sections, search for production cross section, covariances. So anyway, I didn't find what I was looking for there. Apparently ENDF ENDF is not, well, I'm not quite sure what it covers. Anyway, I did see product there, and after some stumbling around here, I didn't see, okay, if you're in here, if you're coming up here, I didn't see that it was doing this, or it didn't click on me. If you, what I would do is take this and move it over and put your parameters in the middle, right where you expect, pay attention to don't stick them underneath as an afterthought, put them right in the middle. I'm at 100% on, this is a 1080p 1920 by 1080 screen, so it's not shabby. It's probably at the low end now of what many people are using. So anyway, so you've got there. So anyway, I did this. So this is induced fission. I can guess that that's what that means. Most people probably wouldn't. So if I were you, I would say, in clear words, induced fission. I'm pretty sure that's what that means, right? Induced fission, YouTube. So now there's 1.92 billion first-time learners in the world, and if we're talking up into the college ages, it's right around 2 billion kids between 5 and 21 who are in the world now learning for the first time. And there's a lot of people who get into the world and said, I need to change because I didn't really prepare and I don't know where I'm going. And so they're in their 30s. So the kids, and then add another billion or so. There's a big lump in the world at young ages. There's a lot of young countries, and most of them are internet savvy or becoming so. Many of them are global in view, and many are trying for, a world-class education. People are not dumb. They may not have the latest cell phones. They may not have laptops and, internet always everywhere where they'd like, but they're no different. And what I'm saying is that they might well want to come and learn this stuff. And where do you learn? The best place to learn is go find the data, find the models, and do that. You can read about fission and fusion and all these things out, but the the rubber hits the road when you get to the data and the models. Anyway, that's the way I'm going. And if I would recommend to all the kids in the world and those billions of young learners, I would say, do this. All right, let's just try this. Okay. Well, a lot of jargon, a lot of stuff. Okay, ENDF 6, I presume, let's see. I'm going to try what I normally would do. Okay, I don't want to lose this page. It probably takes time to generate, or it takes time to bring it from the cache. And I'd like to keep it as a screen so I know where I'm at. So I'm going to try right-clicking to open in a new tab. Well, that worked. So I got an ENDF 6 something or other here. And I looked at all these numbers. And first of all, I think that's supposed to say E plus 4. And if it were standardized, that would be 10 to the 4th. So it's 2.406700 times 10 to the 4th. You're missing it, I think. I don't know yet. I hadn't been able to read this file yet. I don't even know what the columns are. Okay, so this one came stripped. Okay, there's no header, there's no column labels, there's no units, there's no dimensions, and the numbers, as far as I can tell, are not in standard form. Now, you can say, well, I'm just dumping the raw ENDF, and this is, everybody who wants to use this, they're stuck. Too bad. You got to learn our way that we stored them back in 1930 when we started doing this. I actually don't know. I just made that up. Okay, so that's not very good. All right, let's see what the interpreted looks like. So, well, independent. That's cleaner. So it's, but let's see. Here's 2.5 to 1.61. Okay, let's see if those numbers are in there. So that's, oh brother, I hope these are in there. 2566. Let's see, 2566. And I don't know what that zap thing is. Let's see if there are any. 24070. 240, Control F. 2407. No. 2407. So interpreted means I use something else to look it up, but I'm not going to give you the information where I got it from. So that's kind of a here's half of a, so anyway, okay, let's see what else. Is there anything in here? Chromium 25066 252. Here, let's find, that looks unique enough. Let's see if I can find that one anywhere. Okay. Control find, Control B. Okay. So there it is, and there's a 6 there. 845 25067 252 25. Oh, they trumped it or chopped it. Okay, I think that's part. You think that's part of that number? I don't know what these are. So here you gave me blah 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 blah. I might be able to figure. Okay, 0 is actually a neutron, right? No, it's spontaneous. It decays. It's radioactive. So, and it fissions. I can't even know. Anyway, so stuff. Really hard to read. Okay, so it looks like there now. 25607. That was this number. Maybe that one. 252161. That's this number. 2520427. So somewhere on that line, there might be a way to connect it to that. So I've got 2 files. This one I can read. Okay, let's see if it. Okay, well, and it's got this. So somebody did interpreted means actually sort of helped you a little bit. Let's take this. And let's just take the whole control. It's not text either. Let me look. View the source. No, it's a HTML thingy. Okay, so it's not text that you can download, but I can copy it. So let me try that. And I was trying to read this. Okay, so let me get a blank sheet. Go to here. Now, see, HTML doesn't transfer very well on the internet generally. I'm supposed to be I'm the director of the Internet Foundation. I'm supposed to set policies and standards for the whole internet. Okay, 23 years I've been at it. I can't get anybody to change. Oh no, I'm sorry. Okay, right click and paste it as text. Okay, so this is raw text. And these aren't lined up. There's an extra junk. Just delete that. I don't think this is going to go, but let me just see what I can do. Oh, and there's an M in there. So I've got a thing for parsing. I'm going to do it delimited with space. That worked. Oops. Oh, there's a space in there too. 0, you got extra spaces. So there's a space in there. Oh, I don't know what that is. It looks like a 0. All right, let's just see. I'll put that in a separate thing. Let's just take it. Let's just try. Okay, so there was a blank at the beginning, which has made a mess. Here's that. These go. Oh, sorry. It's hard to grab stuff sometimes. Okay, so, and these didn't get read as numbers, so those are not valid numbers. Okay, why? Okay, and I think I know why. So I'm going to the end. I'm going to do this split again. I'm going to do it delimited next. No, it's showing that. Let's cancel that. Let's do it as. Are these number 13? They're supposed to be scientific, but they look funky for some reason. All right, let's see if I can just increase it. Okay, so they're okay. So they just look funny. Then sorry. Maybe because they changed so much from one to the other. Oh, and there's some gaps. All right, so this, because there wasn't a blank on, you see what happened? So, all right, well, that didn't work very well. So doing it that way, let's go back, try it again here. All right, let's try this and see if I can do it as a fixed format again. Let's try that again. So do this one, fixed format, next. Let's turn that off there, take that one off. That's okay, that's okay. The finish, I think I got that one. Those look a little funny. M, oh, we chopped off an M. Oh, all right, so I need to add, let's go back again. Let's see, where am I? So go back again. Do the, oh, one more time. Oh, cancel, back. One more time. There it is. All right, forward, here. This is terrible. Okay, so this is, we're going to try splitting it again. Next, and that one, I'll leave it on here. Okay, so it's going to pick up, it's supposed to, come on, scroll for me. There, okay, so it's going to pick up the M. These guys are okay. That looks okay. Finish. Okay. So with a little bit of fiddling, you can get it. But imagine, okay, I'm fairly good at this, fairly fast. I'm rather casual because I've done this about 100 million, no, not 100, 100,000 times easily, this sort of thing. So, but it's not the way it ought to come. The most available numeric tool on the internet is Excel. Right after that is Sheets, and I think there are 750 million people who have access to that roughly. And actually, with Google Sheets, I think they did a nice thing to make it free and all, but they didn't go all the way and make it a complete tool. But it's out there, so you could do this. So you could, yeah, if you had to pick a tabular format, which I have to choose, my best recommendation would be make sure that it can go into Excel. Okay. Then people can do things with it, and for instance, I could go in and I could plot a curve and see, okay, that came out as not a curve. Let's try it again. So delete it. I still have it highlighted, so let's try this. Why am I getting, oh, it's because of they're internally there. Okay, now I see what's going on. I was surprised. I thought, okay, so now that is intriguing. That is intriguing. I did not expect that. I don't know if it's just because of the things. Let's stretch this out. I'll show you. Format the plot area, right? Okay, over here. Let's see, where is it? Oh, plot area? No. Let's try it again. For chart area. There, size, 25 inches long. Okay, now we're getting up there. Okay, so you can do this, and actually I have some like seismic data I've looked at on here, and I had make it 1,000 inches wide. Okay, it won't. So it's not; those are not completely smooth, which is surprising to me. I don't know how to read that yet. I mean, in the sense, these are probabilities. So if I did these in percents, they're going to be zero, a bunch of zeros, 10 minus 2. So I don't know what that one is. Let's look at the other one. I'm getting a little distracted. Let me get back before I finish. Some of these are like 10 to the minus. Okay, some of those teensy tiny ones down there are down those ones that are these. They're not completely zero, but they're small. And let's just, all right, let's just do there. Okay, so it's doing the same thing. I don't know what the difference is. Well, I can, and they show, they are there. Let's see, 2, 2, 2, they're fairly close. Let's just look at the difference between them. I have no idea if that means anything, but I'm just going to do it. And I have no idea if one is better than the other or not. You know, is there y and dy? Okay, so maybe it's already a differential. So okay, put an x down there, end up. Let's see, I have to do shift in down. Oh, I did it the wrong order. Back to here, Control C. Down, shift, in, down, control V. Those are the weird things. And again, I'm just looking at the things. Let me scroll up a little bit so I have an empty thing here and do a chart. All right, so it's the difference is there, and I'd have to look at the numbers in here. Sorry, I really don't know what's going on there. Maybe 13. They don't look that different. But I don't know what they are. And is there anything in the instructions there? So let me get that out of the, no, y and dy. Well, that didn't help. This one has nothing at all. That was just the straight pop-up, you know, that there. And now, okay, so now I got, okay, so that's where I was. I got that, and I did do a little bit of searching. I had to go all over the web. Let's see if it's on your page though before. Let's be fair here. Reorder by library, so that's not going to help. Let me make this bigger. I'm really having a hard time seeing. Okay. I think this is what I did. I couldn't see the page, so I had to make it bigger. And then when I clicked up here, I didn't have. Let's see. Oh, it was the other one. Yeah, I couldn't see the bottom of it. Okay, so anyway, all right, so let's look at this. Open in a new tab. This one irritated the heck out of me. Whoever did this, shame on them. Okay, don't do that. If you're going to put a link in there, make sure it can be opened in another tab. I know it's probably a JavaScript. That's what it is. It's a JavaScript in there. We'll put in a tiny bit of logic that when you do the result, don't cover up the page that you're on. I can show you that. If you want to, go ahead and make a movable div. I call them hover boxes. Movable, resizable, savable, minimizable, maximizable. Okay, so if you had this, instead of me coming in here this way. Now I could do that myself. I can go in and I can say, let's see if I can get it right here. Open in a new window, and unfortunately, it's not a very useful window. Okay, let's see if I can get this thing where I can use it. It's because you got to do all this fiddling with it. Okay, so I can get here my original context. I don't lose context. I know where I'm at, but then I get here, and then I find a table of numbers which are not in the proper form to use. Generally, almost universally across the internet, scientific E to there, all of Fortran, all the things. This is not a standard format. It's not. And I said, I've been a senior mathematical statistician all my life, so this is about 50 years, and I've been using Excel since wasn't it 1984? Okay, so when the IBM PC, or it's in the 80s. Anyway, so I've seen a lot of data, and I used deliberately in the past 23 years, I've been looking for all the data and models on the internet. It's one of the things that ties groups together. What are we working on? What do we share? How do we do our calculations? How do we compare things? So whatever this is, let me click on it. Well, that was nice. Okay. And it kind of this is what gave me the hint to do it, but it's, first of all, it's too scrolled. I mean, you didn't use the space over here well, your output data, so this calls for a lot of improvements. And then let's see what this form, save this image as a GIF. Okay, well, GIF is okay. PNG. Did I do that? PNG. I'm tired. Okay. And not, don't just, as long as it's not JPEG, you're good. Okay, so GIF is fine. Okay. This is a proprietary viewing format more than likely. And it's, if you want to get to a global thing, you could go out and deliberately send contact information to every one of the, I think it's about 25,000 universities in the world. I don't remember that stuff. I don't keep that stuff in mind. How many universities? Colleges. That's that's just in the U.S. Okay. And I have it turned on to world. I have it set to automatically put quotes around things. I think about 25,000. That's the number I've been using lately. Do I trust these guys? I did some reading. It's fairly close. I'd love to have the exact numbers, but nobody keeps the exact numbers where you can find them twice in a row. That's the problem. You can. They have it out there. It might be authoritative, but you can't find them. And if you do find them, you don't know if they're authoritative, which is part of my issue here with these guys here. I know and respect the International Atomic Energy Agency, IAEA. Okay, you guys have been around atomic energy, wonderful stuff. I love it, and scientific, solid. Good stuff. Not very good on the internet generally. In fact, rather behind everybody else. I'm not just talking. I'm talking about the whole of nuclear physics on the internet is really in a bad state. Okay, you got your really glossy. Here we're doing the latest AI this and then it's kind of shallow, and then the older good basic data is scattered all over and it's really hard to find. And when you do find it, it's in this state. Okay, you guys, this is a good representation of what people normally find. Okay, are there some better ones? Yeah, but what is it? Billions for accelerators, and trillions for reactors, and $5 for the internet. Except. Yeah, I think that from my point of view, in terms of training the next generations for informing and building global communities, collaborative things, not just the people that get paid to do it, not just the people who get funds here. This will support some more graduate students. Okay, there's a lot of that going on. That's where most of the money seems to go. I don't trace that. I don't really care. Nuclear physics on the internet is really tiny. In society, it's probably much smaller than it could be, partly because nobody works together on the internet. So, all right, I'm telling a bunch of stuff. I'm really tired today, so if I'm a little too honest, please ignore that. So this is wonderful. I'd love to know the details in here. I was thinking, I took a walk earlier, and I was thinking about the reactions that are going on in here. So I saw a couple of cute ones. I think it was in here. Let's see, did they have one? No. Let's see, neutron radioactivity capture. This is the kind of stuff you find it on the internet, then you can't get, it's not connected to anything. So you got to take these text strings in here and these words. So okay, they got inelastic scattering. Wow, somebody said, I'd really like to know what that is. But if you go search on it, you get 1.4 million results. And let's look at this one. Okay, so this is what they give you. Inelastic scattering, Wikipedia authoritative, right? Okay, let's get rid of that irritating yellow stuff there. Google did that. I'm pretty sure that's Google, and they didn't ask anybody, and they didn't tell they don't say, well, here it is, this feature. Like, okay, when that was yellow, there should be a box on the yellow, right, that says, here's the person who put that in there. Here's literally the people in the group that you contact if you don't like that yellow thingy, right? That's there's the traceability I'm trying to get on, responsibility I'm trying to get on the internet. Okay, so inelastic scattering, well, this is good, but look how thin this is. There's not an equation on this entire page. There's no data anywhere, okay? So that's not going to work. So I went here, I got to inelastic, so I was reading this, and it's from this context here, there is no thing. Now, this is a neutron, gadolinium. I think I remember all my elements. I learned them. I learned them like when I was 10 or 12 years. No, actually, I was 14. I think 14. Okay. So anyway, 157 gadolinium, 157. I think that's how I pronounce it. So here. And that was one where it made me go to a whole new page. So I have to go back. I'd like to keep it on a separate tab, but frankly, would like to have anything come up right here floating. So if I want to make it bigger, I can. If I want to drag it over to the other screen, I can. If I want to do something with it. So this little button here is kind of irritating. It should open. My recommendation is to make a hover here. And if it stays on there long enough, show the result. Pop it up and make it so you can resize it and stretch it out if you need to, or maximize it if you need to, or drag it onto, right click and put it in a new tab. Okay, but there. So these are England. TR England apparently did a lot of stuff on here. His name comes up. I found some of the papers on there. I found you guys didn't have a link to it. This was what I took the where's your crazy thing again? Okay, so I took this interpreted. I took one of these files and there. Let's open this one again, just so I can find out which one is this. Okay, that one wasn't it because I didn't get anything out of. There was no their libraries ENDF, and it was this one. No, that one. Let's open this, and I can't open that one. I have to do it on this. Let's look at this again. Okay. Oh, it was this. Okay, finally. So I got to here, and now it's on a different page. I lost my contacts. Where was I? But I opened this guy, which I could open at any time. And then there's what I expected when I did this one. Okay, this one and that one, the text of this guy, which here and that one are different. This one has no headers, nothing there. Neither one of those has really clear, general instructions for anybody on the internet, except for somebody who happens to have gone and taken a course in nuclear physics, and they got far enough and they forced them to go in and memorize the ENDF format and learn that god awful stuff. Okay, so here, this could be explained. I'm sure it's out there somewhere, and maybe it's in here. I started reading this, and the problem was there. What's wrong with this? Now, I got this from the internet, right? So it says text output. It's in a PDF, and there's number one major hurdle for the entire internet for all scientific, technical, and quantitative sharing. Okay, number one problem on the internet for that, it gets shoved into PDF. Okay, shame on Adobe for building a monopoly to put all the wonderful knowledge in the world onto paper again, and only paper. You can't get it out of here, and it's not in a form that you can use it. Look. To me, I look at that and I say, a wonderful table. I could in principle, I can take this into Excel. I can sort it. I can recalculate things. I can, like I can take and merge things. I can take these and compare. There's a lot of stuff you can do with it for human in the loop kind of comparisons where you need to look at the fine details. Excel is probably one of the best tools out there. Or something like that. In any of them, you need a table format that's exchangeable. There should be a universal table exchange. Now, if you go in and stick it in XML, you're hurt. That dies after maybe 100,000 lines. Okay. And the problem is, and all the XML formats on the internet are so bloated, they're 10 to 100 times bigger than they need to because they repeat the field names, and they put in brackets, and they put in all kinds. They get over. People go crazy, and they say, look, I've got 1/100th of the actual transmission is data, and the rest of it's names and explanations. A better balance is there. This is too thin. Okay, that one. Let's see. This is really a little bit too thin. You just need a tiny bit more to make this thing. Use tab separation so you don't run into horrible problems out there trying to distinguish a comma in text from a comma there. It's just, I can show you the cost differential of supporting a comma separated standard there. So from a tab control characters is separate from the ASCII characters that are being transmitted. Trivial piece of cake. Split on line feed, split on the tab, you're done. Okay, two instructions. If you go in there and try to unravel somebody's embedded commas and backslash ends and all these other stuff, it goes on forever. I've seen some of the worst messes out there on the internet. I trace a lot of data. Okay, so wonderful, but you can't. Now let's see. I can't even get the whole thing. I can get one page. Let's try C. Control C. Let's go to here. Let's make up another one. Control V. That's what happened. Okay, so it doesn't copy. Let's try this. Let's see if I can copy. No, I did it both ways. I took it raw as an error. So that in this wonderful PDF that somebody generated, that's LANL, S-A Lawrence, no, L-A-N-L, National Lab, Los Alamos, I'm really tired, Los Alamos National Lab, okay, so that's not sharing, okay, because the barrier to somebody using this, just to do the most trivial thing, is too high, okay. Yeah, it's kind of like it's kind of like you give $1. No, let's see. Nowadays, what it is, you give $5 to somebody on the street to buy them a cup of coffee, right? You probably can't hand it to them. Okay, well, I can't make up I can't make up. Anyway, let's just go through it. You give somebody $5 to buy a cup of coffee, but you stick it under a 5,000-pound chunk of lead, okay? And you say, "Here, there it is. I just gave it to you," and they have no way to move that. They have no way to pick it up. Or you give somebody, "Hey, here's a brand new house, free. It's $1 million house. It's for you," and they don't give you the key, okay? It's that kind of thing that now. Okay, so atom, neutron, proton balances, atomic number, those are good. Compounded minus average light mass minus average heavy mass equals apparent new bar. Oh, that's the new bar, the average neutron yield. Okay, that's what these are. It's been a while. Okay, evaluated new bar error. Okay, so maybe so, but I would do a lot more than that anyway. Okay, so these are good. Decay heat, National Nuclear Data Centers evaluate nuclear data file, Brookhaven, blah, blah, blah. More stuff. You can't do much with this in this form. That's where we were whenever 1994. Everything went onto printed paper. Almost nobody was using and sharing anything on the internet. It was the time. And then, yeah, okay, that's an old file and nobody brought it up there, but somebody got the information out of here and they stuck it into these guys. Okay. And it was bad when it went in. Okay, we were at the baby steps back 20, 30 years ago, and somebody ought to go clean it up. Now, all right, I just in my mind I went through all the different ways that society can afford to pay for that. A lot of it is you guys are getting paid to do these big experiments or run this thing. Well, maybe they don't pay you anymore, and so why should you clean up data and share it with anybody? I've been in some national labs, and I think that they often might not have the resources they need. I've worked for the federal government in quite a few different capacities, so I have a pretty good idea. Now that's pretty cool. Okay, this might be mass change. No. 2e minus 5. Oh, that's okay. So there's a letter on the end of that. So that's 6. Let me blow this up so you can see sort of what I'm looking at. Okay. This number here, see this one made it easier. So E minus 7, that's a real number. And for this one, mass change yields, there's the mass number. So those dots on there from here, the scatter in there might come from this mass chain yields, maybe. I don't know. I can't tell from here what those are. I don't know where the data came from. Let's take a look at this. What the heck? Okay, download. Oh, brother. No, that's not download. Okay, it did go to a different page, so I can kill that. Send to brother. Send. No, it wants to download it. Oh, what the heck? .tsv. I'll make it TSV, which is an extension I use for there. So save it, and let's see if it'll. Oh, okay. So there was data in there. Let's get this back up to size. Here, shift in down. Oops. Oh, there's some units on that. That isn't awful, but it should be top and first rather than an afterthought. If you're going to share data, the text ENDF is not the preferred way for most people on the internet to look at. This is not bad, but it's not clean. What would be better would take 10 minutes and write write the display routines in JavaScript and just do it right there. You don't have to generate that. Okay. Anyway, let's see. Okay, so let's take these guys. Oh, and this is here. We can do it this way. Oh, brother, there's some non-numbers and they need to be split. Let's go with data. I have to split it first. So highlight just the data. Go to my splitter, which is in some of the. I took all the ribbons off. Delimited. Oh, I guess fixed. No, let's just do delimited. Next space. That'll split it. Now, let's take that. There, I've got the 3 columns highlighted. That one, this one, that one. All right, so that's not awful. Okay, so that's almost useful. I can kind of get there. So all of the interesting stuff that I want to look at is down here. Did they just ignore it? Let's see. Yeah, 120. Okay, so these are the primary fragments. Okay, so they didn't trace it all out. I was going through that. I was looking at, okay, so the thing breaks up, and it got a lot of energy. How does it slow down? And all those electrons. Okay, that was. I wish I could show it to you. All right, when the thing breaks, there's all these electrons on it, right? Okay, yeah, not electrons. This is the other way around. They're completely ionized. One of the references and books that I ran into, I was just doing a short survey, and it would say, okay, that barium, for instance, I see if we get which one. Barium was completely ionized. That is, it was a Rydberg atom. All of the electrons were gone when it split. So the nucleus comes out of U-238. One part goes over here. The other part, let's see, 238. So this is 100, and then 138 wherever. I don't have fine enough detail. So there'll be one fragment is 100. The other one's going to be 138, right? Or give or so. Okay, and each of those is going to be. That's the atomic mass. Now the Z on it, the atomic number on it, is going to be smaller, and there will be that many levels of ionization. So you got a lot of energy potential there. It's negative, but sometimes that can be useful. So you could use it to quench something. So anyway, I think that would be the. So use my data, select the plotting. So this was, let's see, data for plotting. I'm going to look at this one. That was the same one, it looked like. Okay, begin, AMDFPY. Somebody, maybe ICPY, maybe somebody did this in Python. I don't know what that was. No, AFP1. That's what I saw, FP. I don't know what that there. And then, so these two are, don't say send to. The proper thing is that in ZV view format. Oh, ZVD is there. So, and maybe this was intended to click and send it to it. It didn't clear. So this is either a duplicate because they generated the same thing, or there's a ZV view that when you upload and plot your so they have it embedded and you can upload data. So there is a little bit of, I presume ZV view is JavaScript somewhere. Download. Let's take a look maybe. Interactive plotting nuclear. So this is 1993. They've been doing that. It's still somewhat active. Multi-platform software evaluated efficient plot zoom output Z WinZip. Oh, you got to install it on your computer. What we really need are some really basic JavaScript things, which you can do. It's not impossible. People do it, and all. For the whole of nuclear physics, they could afford one graphical view thing. Okay, if I got into, let's check, site GitHub. I've spent several years now following GitHub. I spent this morning on Chromium. What a project, what a mess. Okay, anyway, let's see, GitHub, ENDF, and this is going to make a mess here. Let's see, ENDF, site.com, ENDF, and that's not going to work. Let's see, I'll do it, it'll come out wrong, and then I'll clean it up. The reason is I have it set so that it's what it's doing is automatically sticking the quotes onto all my searches. I was doing a study. I'll tell you in a minute. So site, there it goes. So there's 1,480 entry points on GitHub where ENDF is mentioned, and I just hadn't had time to do that one. So I went to find your stuff, but whoever I'm talking to here, now I realize, okay, I'm going to be talking to, I've been saying this, I'm trying to write this for the people who did that page, and you know what the chance of me being able to find an email to get to the people who wrote that? About zero. Actually, it's only about 5% probability of finding anybody there who take responsibility for those pages. So I put in a lot of effort reviewing sites and trying to give feedback to some things, and so anyway, there's stuff out there, but these guys aren't working together. Okay, there is no we're all in GitHub together, let's do it. And the problem is they're all coming from every different site, and to my understanding, the national labs just in the United States don't talk to each other, don't work with each other if something will give them an advantage to get contracts and money. Okay, and likewise internationally. So it's everybody's scrambling for money. Everybody's cut the other guy off at the knees. Let's not help. That's the apparent behavior seen from me looking at the whole internet. It is not probably true of any one person. You talk to every person, then they're golden. But when I look at the effect of it is little trivial things like let's get all our websites cleaned up. Let's get our data cleaned up. That doesn't get done. Every single cross-cutting issue, the simplest things that I can think of that you could do just to say, well, look, here's a global community. Here's the basics we need for every single student who comes in to learn this. Every engineer, every company that's in the business, every state that has a nuclear power plant, everything, all of that, it's pervasive. There's stuff all over, but it's chaos. Okay. So anyway, so I just added this to my list. Now this is getting long, and I don't know if it's really helpful. When I get so tired, I get to diminishing returns. Okay. So Zircon. Let's see if that's that's a mail too. So I can Zircon I can use that email, and there now. Is it going to be working? Do you know? Maybe 30%. If I see a thing on a site like this, the chance of it actually being still active and on working. Yeah, 1999, right? So it says 2019, but with COVID and everybody getting ripped out, it's actually that's 11/25, so it's over a year ago. It's almost a year and a half ago. So I'm tired. I can't even do that in my head. So and these are executable. So they're all compiler. Probably old Fortran, who knows what. It doesn't say. Okay, so let's see. How did I got here? You got to go back because it was on a separate page. Now, let's see is there a chance? It says X4 servlet. So I'm in the middle of there. Glossary about. Oh, a few words on ENDF. Let's see what they say. Just, oh my gosh. Single identify. So file, ENDF, MF, MT. Okay, so there's an MT record, there's an MF record, there's a MAT record. So there's MATs, MFs, and MTs in that. Okay, so there's a lot more MTs there. Okay, so I'm skipping there. libraries, all kinds of stuff. That's the way you did it back. Tape, right. So this was tape formats back there. I started with tapes. My very first job was a scientific programmer for the Central Intelligence Agency while I was going to school. I worked there actually full time for a while, and everything was on. Most of the stuff was on tape, and for years actually I was using tape drives and things like that. So satellites. I was doing satellite orbit determination. Okay. All right. So that's interesting. There, and here's Zircon, and that's got a thing. So I'm going to try this, and hopefully that name looks familiar. Sometimes I do things. I even talk to the same people sometime, but I'm getting so I can't even remember all of them. So I'll see if I can get a message to there. I hope this is helpful. It's so hard. You go out and you put your heart and soul into make something like this. It's hard work to get all this in here. I mean, you not only did you do this part of it here, you got all the databases, you've done the queries, you've done the display, you've done the sharing and all, and maybe nobody gives you any feedback on it. Now, it could be a bunch of people come and say, oh, well, that looks really nice, and then they can't use it, and then they say, well, I don't want to bother, and they keep going and looking. I would like to see this as kind of a comprehensive whole. So, I'd love to go look at the covariances. I'm a statistician. Covariances sounds like fun. That's great stuff. Let's look at the cross section. Let's find the models where they actually use the cross sections for chains of all of the reactions. I was in my mind. I was going through all the possible, secondary, tertiary, whatever the new words are, 5, 10, 20 levels down. The tiniest little electron from a beta decay, maybe it could go in there and do something. I don't know. I don't leave out the smallest thing. When I was looking at the neutron cross-sections in there for fission, it's the slow ones that are effective. And if you're in a fast neutron reaction starting out that way, or you're doing I was going through accelerator fission, actually collision-induced fission. I was looking at that just a little while ago, and then I got distracted on this. So when you do that, the fragments are going out there. If it's in a plasma, a dense plasma, or it's in a solid, what are all the secondary? If like when the cosmic ray hits the atmosphere, it gets muons and a radio impulse go out from there. I'm following all the neutron, or all of the cosmic ray product detector networks, if you can think of that. So there are electromagnetic detectors. There are direct cell phones. Okay, you can pick up cosmic rays on your cell phone image sensor. Okay, they got software for that. You can pick up in the software-defined radio networks. You can pick up the static from it. They're in the lightning detection network. I bet they can do it. There's purpose-built low-frequency array. I don't know all of them. I can't even remember. I'm just saying electromagnetic and every possible one. And there are a bunch of them. I go find them. When I'm looking at them, I'm very professional and careful, and I don't leave out a tiny bit. But right now I'm really tired, and I just can't remember all the magic words. So I memorize them. I use them. Some of them I've known my whole life, but every day having to go in and try to read somebody else's stuff like this, and not many people are helping. Okay, they say, look how hard it is for anybody, and 2 billion. I'll try to keep this short. 2 billion kids. Okay, and anywhere from I could read data when I was 15. Actually, probably younger than that. Okay, so basically that says I think that there's about 6 years in that group. So that's about 500 million people. Let's make it simple. There's 500 million people in the world, first-time learners who could have been exposed to enough math and equations and things to probably look at these graphs and do stuff with it. I think they're teaching nuclear physics down in the grade schools because it's part of life. Everybody needs to. Every kid probably from the second grade is hearing, wind energy, nuclear energy, coal, air pollution, carbon dioxide, all that stuff. They're all. I'll go check. I say these things, and it's a reminder of me. Have I looked at that lately? And then you go in and say, oh, okay, yeah. So let me finish. So, all right, let's take 500 million people, 1 in 10,000. Okay, 1 in 10,000. So here's my 0.5 E9. There's my 500 million, and divide it by 10,000. One person in 10,000 who would come and look. That's 50,000 people in the world who might very well have a oomph to come and look at nuclear data. Okay, and we need them. Okay, I'm working now. I'm tracing out. Could we go back and finish up the nuclear? No, not nuclear. I use a term. I got a term for it. Okay, atomic energy for fuels. Atomic fuels. We could build them. We're going to need them. If you go out there, I don't think Elon Musk was asking for it, but if you go out there and do the numbers on solar system colonization, even just moon stuff, you can't do it without atomic energy. You can't. The original peaceful use is practical, low cost, safe, energy free for everybody. That's possible. When I'm talking to people about Mars, and they ask me, they said, well, Mars and the moon. I said, where do you get your oxygen? I said, you get it there. You say, it's kind of a joke, maybe, but you go in and you scoop up some soil, which is about half oxygen, your oxides, your iron oxides, aluminum, and I don't know what else, magnesium, manganese, whatever you got. You dump it in your Mr. Fission atomic powered melter and electrolytic separator, and you get oxygen at one end, you get metals at the other. You use the metals to build things, and you use the oxygen to breathe, and continuously recycle over time. So those are the things. The world is changing dramatically, and what it looks like it's going to do, if the solar system colonization, kicks off like it is, we could have ships traveling around the solar system like we had airplanes traveling around the world. Okay, the same level of flexibility and movement and the dramatic demands for new industries and technologies there. So I track everything. I track gravitational imaging arrays, and I'm too tired to do it. So I like to look at this. I really hate to have to go in there and just say, well, okay, I'll go back to basics and read all the ENDF stuff. Somebody must have cleaned this up already, better than this. I know IAEA is one of the oldest, and maybe it's underfunded, and this is a labor of love that I forget your name, the comments and look, feedback. That is V Zirkin. Okay, so you got one here, You had your name in several places. And I can't scroll down. There it is again. Okay. I think generally what I would do, a database manager, web and database program. So you've done a Victor. There it is, Victor. Okay, great. Sorry, I'm so tired. Victor, I'll see what I can do to help you. I don't know what. I don't know. Oh, FTP. Oh, it's okay. Okay, it says there, download. Files for FTP. FTP in the United States, all the government agencies can't use it anymore. It's a security risk. And so, like NASA and those guys, they can't use it. And you go there, what happens on the user side, it just hangs. It won't even tell you. And then maybe after 5 minutes or so, it'll come say, oh, no, not connected or something, or connection failed or something like that. But what it is they want everybody to be secure HTTPS, right? And the old FTP just simply won't go. So anyway, so temperature dependent point wise, these look interesting. I'm getting distracted. Okay, let me stop here. Data. So, what is this? Oh, this is an HTML page. Astrophysics temperatures. I want to look at the 100 electron volt. Yeah. Ah, that's cool. Okay. And you have lithium 6. Okay, so these are, that's what I'm going to have to expect to see. Oh, brother. So it's all, you got to write a parser in here, a text parser to get all this stuff out of here. And, brother, what's that number? They let them run together. So this is a fixed formatted. You have to know there, and it looks like it chops in the middle, my guess. Let's see, 16. It looks like there's a split right down there somewhere. Okay, so fixed formatted thing. Text headers that are maybe fixed format. So this is old Fortran stuff. I learned Fortran in high school. I was doing random neural nets and designing robots and artificial intelligence in high school. And the first day I got to Case Western Reserve, I found out they did algol. They were using algol. I thought, oh my God. So somebody there had an algol manual. I read it. I went in and got a job the next day with the mathematics department teaching algol to the kids, the numerical calculus. I've been at this a long time. I'm very, very good at it. It's a little overwhelming and daunting for one person to try to do all the data and models on the internet, but I think I've been at it 23 years. I'm doing a decent job. Sometimes I can get a few things changed. So, R matrix. I just did a bunch of stuff on the R matrix just the other day. I store things in such chunks that I have to like meditate and bring them back up again. So it'll have to take me a while. I know I can remember that I did that. There's that one. That's a different one that I was looking at, but I'd like to see all the light things. So astrophysics is one of the biggest growing areas on the internet. It is exploding out there with the gravitational, LIGO stuff, all the gravitational wave stuff. It is going crazy, and with all the satellites and telescopes and things out there. But what they really need some better nuclear data. I'm pretty sure the neutron, all the stellar model guys could use a better basis of the nuclear reactions. When I was thinking about all those reactions, that's what I was thinking about. Are they in a good enough shape that they're complete enough that you can really go there and tap that and test it? So I'm always looking for ground truth for everything. So if somebody's doing one thing, then go there. And I tell this story. I'll throw it in here. I'm cramming in as much as I can. The seismometers, broadband seismometers in the world right now, are actually at least three kinds of detector. Even though ostensibly they measure velocity, and displacement for seismic waves, they also pick up acceleration, and they're sensitive, some of them enough to be used as a gravimeter. Pretty coarse grain, but there's a couple of things I can use to test and say, yes, indeed, they work as the seismometer array as a gravimeter picked up the Japan earthquake signal, the gravitational signal. What it was, okay, think of it in a fixed Euclidean space, the density of some of the voxels changed, and that changed the gravitational potential, and it transmitted at the effect transmitted at the speed of light to the detectors. There weren't many running, so some of the broadband seismometers picked it up, and the superconducting gravimeter network. That's it. But now there's groups, because of that, they're out there looking to make more sensitive, faster, time of flight, 3-axis gravitational detectors. And so, all right, so I'm going all over the place here. Let's see what R matrix. I think that's, I'll have to look at it again. The neutron star modelers. How many things do you throw in there? There is a nuclear magnetohydrodynamics. Okay, the magnetic part of those things, that's going crazy. They're trying to do that. The plasma people want the magnetics better, and the neutron star guys want better magnetics. Everybody's testing that, and everybody's scrambling for the data, and every single bit of data out there is in a bizarre format. Okay, and so I have a little idea that we could go out there and use this data set to confirm what we're doing over here, and then you spend hours or days or months or years on it. Even a smart guy like me, if I have to go in there and slog away, for days just trying to read one ENDF format there, because so much is squirreled away. Well, I read some of these things. I went to a few things, and the problem is a lot of these things are like little notes, like handwritten notes that people put in here. So there's a lot more in it than there. Oh yeah, well there's some big long list of things that are there. I don't even know why these things are. It looks like there's a table here. It's almost like there's like text paragraph and then a table next to it. There are better ways to do that. If this were just an HTML split out where each region had a separate data content, then it might be better. But this looks like, I don't know what these are. The 14, these are going down, so these are sequential. So the last number there, 1451, almost looks like a identifier code. 325, I don't know what they are. ENDF format. So GM Hale. Okay, I can't find that guy. Okay, who is he? Where is he? 2009, he might still be living. So, how do I get from here to the? It's the community. I look on the internet, what's fundamental? You have to be able to trace it down, not to another, data set, which is nice there, but ultimately the data sets don't have enough information. The key information is in somebody's head. Alrighty. This is enticing, it's attractive, it's fun, and it's frustrating as everything. So, radioactive decay data. Nitrogen 16. Thorium decay. I'm just curious. Alright, some of that. Let's do the plot. Oh, that's cool. Uh, Whoever's doing this, there's some fun stuff. These are great visualizations, but they're not in a portable format. Okay, which means that means a whole bunch of stuff. Let me try this. Okay, so it plotted on a separate page. That's good. I don't know what this JS. I'm afraid to try. Oh, that's interesting. Oh, it was JavaScript. Okay, so this is a JSON. That actually stands for JSON. This is a JSON format. Sort of. It's readable. Okay, so some of that's good. And interpreted, that's back to this listing. Oh, that's different. Totally different. Okay, the header up here is branching decay. And those are broken into pieces. There's no identifier for the line type, so you can't parse it very easily. You have to know what it is. Okay, and this one, and then this, and there's the unlabeled stuff. You can go in there and stick a header on these guys and just say, here, these are header lines, and then put in a block, right? Just put in a break. So you don't have to, just because this is the way you get it, you do not have to send it out unheadered. Okay, unlabeled, untraceable. Okay, particularly it ought to say, you see this thing here, this ought to go in there. If I were saving this, I normally what I do, I'll copy that and stick it right into the top of the file, just so I can get back to it again. It's not really certain that you can, but it's better than nothing. If I save this, I can't. Let's see. Save as. It gets saved as a text. But exsg get sex. It's named by the program that did it, not by the content. So if you're going to give a default name to thing for downloading purposes, you should probably make sure that it means something. Okay, and that text didn't come in. So it got named by this, but it probably should have said that plus 83937099 607, all the codes with some real meaning in there. All right, that's the best I can do. I talked more than an hour again, but and now I got to go back to what I was trying to do, was just to understand this, and I want to look at all of the consequences of each decay. Okay, I want to take every single fission product, particularly if that is true, what I saw in there. They said they did a fission reaction, and if I forget Barium's number right up. Oh, maybe I have it here. Let's see, I did. Okay. So what they said was, U-235 goes to strontium and xenon, okay? And it was strontium is 38, and they said strontium 38 plus, and they said xenon 54 plus. Now that intrigues the heck out of me, and part of it is I've looked a lot at Rydberg atoms. And so, are these truly always coming off as Rydberg atoms? If you had something like, it's a neutron that started this off, so it's fragmenting. Does all of the energy go into the electrons are there? I guess they're so far away. It's so fast. That's a lot of energy. So it's so fast. The electrons don't have a time, and then the fragments take off like crazy, and they strip off and leave the electrons. Where did the electron go? That is, now let's see, so the uranium's just sitting there. It fissions. The neutron's coming in, so it's sitting at rest. Neutron hits it, and you get 38 plus 54. That's 92. All 92 electrons go somewhere. Where do they go? Now, if I were in power production and doing a direct nuclear to electric sort of a project, I would say there's 92 electrons that might be useful for something. I don't know if that's going to work. But because, say I pick a problem like that, I know I'm going to really love. Okay, so I come up and I say, oh, that sounds like an interesting idea. Let me go check. Do you know what I'll find? I'll find, let me turn off my settings. I want to do something. Let's see, settings, search engine, Google. I got it. It's clumsy the way they do this. They won't keep the one I use all the time. The ones that I do use all the time, they won't keep them in here. So Google, let's see, where was it? No quotes, there it is. Make the default. Okay, they won't do it. So what I'm looking for is, let's see, fission, Rydberg, electrons. See what they say. Atom during nuclear. Okay, many of the undergoing fission. Okay, so here's somebody, and quantum state control of ultra cold plasma fission, gas to plasma enter the heat to 100K or more. Rydberg gas. This is exactly what I expected to see in here. Okay, people are going to be working on this. They say it's an obvious thing to do. Where did the electrons go? Okay, now this is ultra cold plasma. So what they're saying is, formed by the pinning ionization closely, maybe pinning ionization. There, we'll have to see. I did do there, but it's saying fission, so I'm gonna go and check. Let's just take this one. Normally I do it on positively charged emission spectrum. It's going to be a Rydberg spectrum. Okay, they just standard old Bohr atom, electromagnetic force, electrostatic. Oh, there's some good ones. Let me blow it up so we'll see. Okay, polonium. Okay, is that polonium? Phosphorus? Radon? I'm really tired. Okay, so blah blah blah. Those are all kinds of different decays. Usual half-life, fission, undercurrent. Okay, well, it didn't get there. So that's how fast I have to read, and how many. And I'll probably, for this topic, I can tell you to get a good sense out of it, I'll have to read about 50 or 100 of those things. So there's the first one. Let's go. And the quantum state control. I keep track of who are the people that are involved. Quantum state control. They're I'll check ultra cold plasma fission. And there's a case where I'll copy that, and then I'll stick quotes on it again. There, I manually. I do a lot of that. So ultra cold quantum, same one. High energy density plasma, ultra cold plasma. The thing is all of the a lot of the quantum experiments go down in the ultra cold, and so what you'll find is that some of the best mathematics and modeling and simulations are coming out of the quantum groups. Not out of traditional nuclear, not out of astrophysics, not even out of some of the guys who went with stochastic modeling. All the at UT Austin, I was there when Ilya Prigogine was there, and that's statistical mechanics. That's what I was trying to remember. That kind of group, so it's not there, and they were doing chemistry. Okay, those guys were primarily chemists. We were doing the chemical clocks at that time, and so all these different groups out there, everybody speaks about the same fundamental things. They end up a lot of times they use the exact same mathematics and models and almost exact same names, but on different processes and things, and then they don't talk to each other, or they use different mathematics on exactly the same thing, or they have the same thing with different mathematics. So I see every possible combination of it. And sometimes the solution to these, I'll see the solutions in here because I'll go through 10 or 50 of them or 100 of them, and then you'll see where it all fits together. And usually it's outside. So the people that are looking at ultra cold plasma fission, their answers are somewhere else. Okay, if they're stuck on something, it's because the answer is not in their group. You get what I'm saying? It's really a trivial result, but I use it all the time on the internet. So you go out there, and if somebody's stuck on something, it's because they're looking under the street lamp there, and they're looking in their own group, and they're not going to find it. They need someone from the outside. And so multidisciplinary takes on new heights or dimensions when you go on the internet in these days. And I pick up topics, and and the first thing I said, this needs about 100,000 people. Okay, and the reason is that it's such a tough thing that if you go and trace out all the pieces there, but it's not that hard to get 100,000 to find, identify, and connect 100,000 people nowadays. It's almost trivial internet stuff. Okay, it's down in the hundreds of thousands of dollars or millions of dollars type of effort. Okay, there. Now global COVID, I'm trying to do that cheap for a few $1 million worth of people's time, but it's not impossible. Well, this looks like fun. I'll just stick it in there. I got kind of distracted. I didn't there. So, you guys, I just envy the people who get to work on these there. But I also don't envy you if you're sitting there and you don't have global communities, and you don't have good internet support. You don't have somebody looking, say, let's do all the nuclear stuff. Let's not stop. Okay, IAEA, well, you do your thing, and you have to pay for everything yourself, and we're not going to help you. Or I don't know if that's going on or not, but even all the nonprofits that are looking at ENDF there. Yeah, 184,000. That's about reasonable here. It's a small group, but mature. It's been around. That's enough. And there's a bunch of there. Wikipedia, Department of Interior. Okay, Europeans. I think ESO. I can't remember all those conferences. Archive. Okay. There. Anyway, I know so many issues on the internet. Every group has stuff going on. G4F, Semantic Scholar, the publishers, Oak Ridge, PRG, Potter. I know there was a bunch. They don't have an org. They need a GitHub.org there. I think there is a corresponding one. GitLab, maybe. Is that an org? So, e-scholarships. Okay, so, yeah, this is not the... I can tell from the... Is there... Let's see what okay, ENDF. Yeah, let's get the director, North Carolina. The universities are pretty bad. The EDUs and the AC country things, they do a lot of stuff, but they don't really support the students very well as global communities, and so people are not really portable as they should be. They're still doing these massive, 5,000 people on a paper kind of projects. Same thing, nuclear physics and a bunch of others, but it's not there. This is all standard stuff. Oh, that's interesting. I didn't know they did those. Crap. Oh, that's cool. So somebody's doing, there's materials as well? There's so much I don't know. Okay. I wanted to be a chemist. Very first thing when I was a kid. And I memorized the chemical composition of everything. Everything. You know, I'd look at something and say, what's it made of? What's it made of? What are atoms? And this is kind of cool. Oh, let me let you go. I'm sorry for running on so much. When I get tired, I want to keep going because there's so much to do, and I just wish I could just pour, years, decades of work that I've done, finding stuff on the internet and how it all fits together, how you build global communities. It's so easy. It's not. I call it. It's not hard. It's just tedious. Okay. There is no problem anywhere in the human species right now that's impossible. It's just a matter that it takes effort, and you would know that, Victor. You would know that because look at all the hard work that you've done. And you know that if you do it right and you get it right, then it makes a difference. So anyway, I'm sorry. Talk to you later.